detail as Brent's was. I've chosen 3 subjects. Front end alignment, we'll go through briefly. Safety, lights on the back of the vehicle in particular. And the last one would be on pan straightening without a pan straightening jig. So let's go start here. So front end alignment, the geometry on the front end of is very important. There are 5 main points of the geometry. Front toe, Ackerman, caster, camber, kingpin inclination. We'll go through each one of those. There we go. Toe in. This is fairly important to keep the car going down the road in a straight line. Front B is smaller dimension than the rear A. That's why we call it toe in, because the front wheels are towing in. You don't want them towing out. The big question is how do we measure that and how do we adjust it? Well, we adjust it by the track rod. One turn of the track rod on the thread is like 40 thousandths, so it's fairly fine. What I come up with is this device. It's not a walking stick. What we do is put it between the wheels. On the end there's a little button to recess in. You put it on the back of the wheels first. The optimum way is to measure from the ground up the wheel 15 inches. Put a piece of tape on both sides, and that's where you try to get this lined up with those so it's in the centre of the wheel. And then when you put it in between, you'll see this is spring loaded. You measure the distance between the two, record it, and take it out. Move the vehicle forward until the tape is now at the front of the car, and you measure up 15 inches, make sure you're there. Put this back in, then measure either with a vernier or a scale, and then you can subtract one from the other, and that'll be your toe in. Fairly simple, fairly accurate way of doing it. There are several other ways of doing it, pieces of string, tape measures, but that way is, I find, fairly easy. It's an easy thing to make. Piece of tube with a hole in the middle, spring loaded. If I pass it round, don't push the end off. I think Henry Ford spec was something like 3/16 to a quarter. I find that a little too much. I usually go 1/16 or an 1/8 for my cars. It seems to work out quite well. The next one is Ackerman. Does anybody know what Ackerman is? Yes, no? Alright, Ackerman was invented by a man called Ackerman. And on the right you'll see the steering arms, and there's a dotted line from the centre of the kingpin through the centre of the steering joint, and it intersects with the centre of the rear axle. And that's important, because when you go around a corner, one on the left, you'll see if you intersect from the centre of the kingpins out to this point where it intersects with the rear axle, that inside wheel is turning more than the outside wheel because it's a tighter radius, and that helps you get round the corner more. And it's all about the angle of the steering here. See they're angled in, and that point intersect here. And that's how they get Ackerman, and that's how you get the wheels on the inside turning more than on the outside. And obviously on the other side it's the reverse. Okay? Very simple but very important. You're going the wrong way. Okay, caster. This is also a very important one. you can get this very seriously wrong on a Model T. On the left there's a picture of the spring perch. You can see the different, see the angle there? That's what gives you your caster. If you put those in the wrong way round, you're going to get positive caster. And that's where the kingpin leans forward and not back. That's a dangerous situation. So you want to be 5.5 degrees is what the spec is, laying backwards. Now, how do we measure that? Henry Ford Henry Ford used this method. Square on the floor and you measure the top. I came up with a different idea. Piece of plastic sheet, piece of metal on the end, an inclinometer or dividing plate board, clips on there. There. And you put the top of this one and the bottom and the top and bottom of the kingpin nut. Okay? And that will measure the reading up here will measure your angle. Pretty simple. If you've got the axle out and just put the kingpin through there, you can just put that on there and measure it as well. But it's just a bit more accurate. You've got to make sure the car is on a flat, level ground. Otherwise, you're going to take into account the floor running out. But that's a fairly easy device to make yourselves use. So the important thing is to make sure when you've got the axle on the car that the axle is laying back. Because you can put those spring perches different way around. You can put the axle on the other way and you're going to be leaning forward. So make sure that you have got that 5.5 degrees laying back because it is very important. And if you have too much caster, it's going to really make it heavy steering. The less you have, the lighter the steering, but it's going to be more of a danger point.
I've got a microphone if that would help. If that would help some of what you got. All right.
Thank you.
Yeah, that's on my speed, so that's 5 degrees.
Put that button on.
Right.
Thank you.
That gold down there is what you're adjusting it with, and the other picture you had.
Right, well, to adjust the caster is not easy. Okay. This is what Henry used. Is that better? Is that better?
Is that better? I can't turn too much.
Okay. So this is what Henry Ford used for adjusting the caster. It's a rather large pair of what I would call stilters or pipe wrench, and it's placed over the axle beam, and you just literally bend and brute force bend it. Now I don't think you're going to bend that axle. I think what it's bending is the wishbone. That's what it's bending. But that's how they adjusted it. Now I don't particularly like that idea. I would rather take the wishbone off and heat it and bend it a little bit and try and put it back again and get it right that way. But that's the way Henry Ford did it. I haven't actually seen one of those, but I'm told they are around. Okay, now camber, this is an interesting one. Camber is where on this car the top of the wheel lays out, positive camber. Typically today we have negative camber because when you go around a corner the wheel is going to stand up more and it gives you more contact on the road with the tyre. Henry used camber, in my opinion, to give you what we call centre point steering. Centre point steering is where you take a line through the centre of the kingpin and then the line through the centre of the wheel, those 2 points meet on the road, that's centre point steering, and it makes it easier to steer. And I think he used a lot more camber than he needed just to give him some centre point steering to make it easier to steer, because they did not understand, I don't think at that point, kingpin inclination. There is no kingpin inclination on a Model T, it's vertical. And what we need to do is lay it back like that. I'll get this right in a minute. Okay, that's kingpin inclination, which I think the Model A probably had it, but the Model T certainly didn't have it. The kingpin is vertical. As you can see, by laying the kingpin back, then the 2 lines will meet much closer to the ground. And that makes it easier to steer too. It also does other things, but I won't go into that. It's more of weight transfer. That we don't need to talk about that on the Model T. This is an interesting fact. The front axle, it started life as a piece of 1 3/8 diameter by 67 3/4 of an inch long. And after going through various stages of forging, as you can see, it's taking more and more shape as it gets to the top. And the front axle then ends up as 3 inches wide. And I just found that interesting to see that they started with a round piece of bar, and they must have went through an awful lot more processes than what's on there. But and their forging machines, they must have been horrendous. I don't know how they powered them, but back in the day, I mean, you're talking about back in 1900, 1906 or something like that. So that's just an interesting fact. Okay, any questions on the front end alignment? No? Good. Okay, safety of a Model T is of utmost importance to me. I worked in motor racing all my life, in cars for 20 years, so I understand what safety really means. On a Model T, we all put our collar pins in and make sure we wire lock things up. But one of the things that I think we're beginning to realise is that we need some more identification on the back of the vehicle to make people approach it from behind, that they're approaching a lot faster than we're going. And I think there's been quite a few serious accidents where people have got to the back of the Model T before they thought they were going to have a serious accident. So this is just a little bit of math to tell you that if a Model T is travelling at 35 miles an hour and the vehicle is coming up behind you at 60 miles an hour, that's a closing speed of 25 miles an hour. That means that the vehicle is closing at 36.66 feet per second. I know this might sound a bit boring, but these are facts. When that vehicle behind is at 200 feet out, it's going to be up your exhaust pipe in 5.45 seconds. I hope he saw you before he got that far. That's how serious and critical it is. That we need to be more aware of that. So what I've done on my speedster, which I built last year, I put LED lights on it. And LED, if you read the forum, there's a lot of talk about LEDs. You can't use flasher units to power LEDs. You have to put load resistors and that sort of thing. That's a load of nonsense. These I found recently, and I think they make really good lights. They're actually for a Model A. They fit into a Model A rear light. They have bulb bayonets on them, so you can actually plug them straight in. But I've gone a step further with this. You can buy these for about 26 bucks a piece if you search online. You can buy them with yellow red like this one, or red. There's 2 options. hadn't seen any 6-volt ones, these are 12-volt, so you'd have to look for that. Okay, what I've done is modified the wiring slightly. What I've tried to do is make this 2-light unit into a 3-light unit. And by doing that, you can have side light, and there's a small resistor there you have to add. Then there's a stop light, which makes it, turns the same light on brighter. 0-volt obviously, and then the lower one in this case is the turn signal. That is the red unit. When we go to the amber, like this one, it's a slightly different wiring process change. There's no resistor, but the top one becomes the turn signal because of it's amber. 0 volts are the same, and then the bottom one then becomes the side light and the stop light. Now you don't have to wire all that in as they, you can just use them as they are here. But let me just show you, I got a demo here. This is turn signal. Right, left. And then you can also, with I'll show you the circuit in a minute. You can do hazard lights as well. 2 switches and the correct flashing unit, electronic type flashing unit will do that. There's the stop lights, side lights, turn signal. With all that working, that's drawing half an amp most. So if you have a battery like that in your car, which is a 12-volt, 14 amp hour battery, you could run this for 20 hours with all those lights running. So it's really not really This is the circuit that's inside that black box. It's really simple. A flasher unit, there's 3 terminals on, 0-volt, 12 volts and signal out. There's 2 switches. These are the important bits. The one on the right is the turn signal switch, and that needs to be a single pole, double throw. You'll see that on the packet when you go to buy them in the shop. That's an on, off, on. So in the centre position it's off, on the left it's on the right it's on. That's your left and right, for your left, right turn signal. On the other side is a hazard switch. We just wire that in a similar way. That's a double pole, double throw, on. And that'll give you all 4 or 2 if you've only got 2 on the back working. It's a fairly simple circuit. One of my golden rule with the Model T, because of the magneto and all the coils, there's a lot of electrical interference around the car. The golden rule is always, or don't use the frame as a ground. Run a wire from the battery to your lights, a ground wire, and then you won't be picking up spurious noise from the magneto and the other stuff that's going on there. It's fairly simple to do. If anybody wants to go through, like on my website, which is TW Components, you can download this whole story about how to put LED lights in the back of your car with this circuit. We can also, I think it also gives you, there's the electronic flasher unit. It's an EP35 and I bought it from AutoZone. It's that simple. You just have to get the right one. The reason, if you take an old-fashioned type or a non-electronic flasher unit, there's what they call a bimetal strip in there. And when you turn them on with the incandescent bulbs, draws a lot of current. And it warms that bimetal strip up, and opens the contact. Then it cools down and closes again. That's how you get the thing flashing. But with an LED, you're not drawing enough current to do that. So you have to have an electronic one. And inside an electronic one is probably a small transistor, which is turned on by the current being drawn by the LED, which is very low, and it works just fine. There's no need for a load resistor that people put in. So any questions on turn signals? No? Okay. Pan straightening. When we build our engines, one of the most important things is to make sure the pan is straight. The fourth main is in line with the other three. And there's a very heavy, you've seen it, a very heavy cast iron flat table, which people have, some people have, but they kind of go for about $4,000, which is quite a lot of money. And if it's just used once or twice a year, it's a pretty expensive thing to have around. I came up with another approach to doing it, and that, look at this. Oh, as strong as they used to be. This is a piece of steel that I had turned for the three main bearings without babbitt. And on the end there you'll see a spigot, which is for the fourth main. You don't get that fourth main. That's, you can pass it around, you can carry it.
No. Oh, good. Let's add more weight.
This will test a muscle, won't it? So what we came up with was a very large piece of channel, which you just happened to have laying around the workshop at the time, but something like that you need. And then take an old scrap cylinder block, turn it upside down, bolt it to the piece of channel, okay? And then with your mandrel in place, you put the sump pan on. And there's the end of the mandrel sticking out the back where the fourth main goes, okay? We've got the sump pan on, and we've also got the hogshead on. That's not particularly important, I don't think, to put the hogshead on. But what we do is slide the fourth main on and see if the four holes line up, or if the two holes in the sump pan line up with the fourth main. If it's up or down, then you've got to bend it. And the way I do it is heat the front side of the sump pan, and then with this stud and that plate, I pull or push up and let it cool, and then try the fourth main on again and I get it, keep doing it until I get the four holes lined up. Like that. Now if you want to make sure where the legs on the sump pan are, you can measure that from dimensions of the chassis and things like that. You can just lay it in the frame and see if it all lines up. But that's the most important part, I think, of lining it all up is the fourth main. So, any questions on that?
Why does it get bent? Why does it get bent?
Good question. I would suspect because of the way that the whole thing twists. You know, the frame is, and the axles are, the whole thing twists quite a bit. I think the other possibility is the wishbone is attached to that sump pan, and that's the area that I would normally heat up before I start pulling and pushing it. And I think when you go over a rough road and potholes, it's pushing that axle back and pushing that wishbone into the sampan. And I think that's what, it probably isn't quite as bad with the later blocks where they have two bolts at the top to bolt the hogshead on. With the early ones, there's nothing that ties the hogshead to the cylinder block. It just sits on the pan. So I think that they're more vulnerable than the other type.
Hey, Tony, I have a question. I have a gentleman that had a question, and you know I'm not a car girl. Okay. That big heavy thing we passed around, what did that start out as? Is that what?
Yeah, what diameter start out?
No, I think it's about, I don't know where it is.
Back up there.
I would guess it's about 1.5 inch diameter, just a piece of bar. It doesn't have to be, it could be 2 inch, it could be, it's just going to be bigger than the journal size. And if you make it for the cylinder block without Babbitt, and just keep that block around, you know, it's something you can do as a club and share it around. It's very simple to do, but you don't have to buy a sampan jig for $4,000. We'd like to see one in the workshop if anybody wants to donate one, by the way. But.
Thank you, I'm sorry.
Where around that wishbone connection do you keep that man? Where is it more?
Yeah, unfortunately I didn't get a photograph of it. The sampan comes along where the inspection cover is, and then it comes up like this at the top of the I call it the bell housing part. And then on that face is where the wishbone is attached. I usually heat it up below that towards the outsides. It's kind of cherry red, a little bit cherry red, and then just pull and push on that with that stud, and you can get it quite accurate that way, quite easy.
A related question: when they had a flat cast iron hand braking jig, what did they do? What was the suggestion?
I'm going to say brute force and ignorance, but I don't know.
That was my understanding too.
I've never seen anybody use one. All I can imagine is they beat it and twist it, and maybe they use some heat, I don't know. But if you've got it laying flat and you pull it down with the bolts, as soon as you let the bolts go, it's going to pop up again. Well, maybe if you heat it, it might stay down. But there's no way of checking to see if it's in line. This way, you've got that mantle in there, and you've got the fourth main going on, and you can make sure that your bolts line up.
Looks like a great idea.
All good ideas are usually simple. I did miss out on the camber a little bit. Let me just go back to that. This was the start of a camber gauge. Just a piece of plywood, and you put it on the wheel, on the rim of the wheel. Yeah, with this handy tool, I bought this from Sears, I believe. You just hold it on there, and you can measure the camber. If you put a piece of metal on here, obviously it's going to stay on, and that's it. Like I say, it didn't get finished, but that's what that was for. I know there are various ways of measuring all these dimensions, but that they had with squares off the floor, and they all work. I just think these are a little bit easier, a little bit more accurate way of doing it. Any other questions? Good, I'm clear to go, huh? I would like to just say a couple of words about the museum and this annex building and workshop. A group of us from the Indy 500 chapter decided that we would come over and help Jerry Kramer and Susan Yeager, who do a fantastic job over here. We decided we would come over and help out, do some work here. That was a year ago. We didn't think we would be spending that much time on that much work, but the workshop in there is the first thing we worked on. There were other members from other chapters around locally that came in and helped. This room here has been painted, the ceiling's been painted, the walls have been painted, all the boxes of stuff have been removed into the other side. It's all volunteer work. And what I'm trying to say is that what we try to encourage chapters to do locally within 75-mile radius of the museum is to put together a group of guys like we did and come over and ask Susan, what do you need doing? She'll give you a project. Take that project, do it, finish it and go home and wait for the next project. But if we all the surrounding clubs do that, like the painting in here was done by 2 or 3 guys from a local chapter. The more volunteers we get coming over in groups like that, the more we're going to see changes to the museum and these additional buildings. I always say with the museum, if you go back a second time and the displays are the same and the cars are the same and nothing's changed, there's a good chance you won't go back a third time. So it's very important to keep that change going, keep the displays moving around, get different cars, different displays in there, and that just encourages people to come back again. And one of the main points of this workshop here, yes, it's a working workshop. You can go in there, in theory, that's what we're trying to achieve, is you can go in there and take a car in there and work on it. But the other thing is, it's going to become an education centre where seminars like this, but I can see in the very near future that we're going to get school kids from the local schools in here. The earlier you catch them and encourage them to understand what an internal combustion engine, that's a simple thing. You get their attention, that sticks in their minds, and those are the people we've got to encourage, because as we get older and we fall away, it's the next generation coming up that places like the museum is really needed. So if you're from a local chapter, try and bear that in mind and talk to the members when you get back at your next meeting. We look forward to seeing you here as volunteers. Thank you.